Hello. Our presentation is a cold weather air source heat pump cost effectiveness analysis. Giving this presentation today is myself, Colin Cleveland, Dalton Buck, and Samuel Schroeder. Before beginning our presentation, we would first like to thank Kevin Eggert and the Mechanical Sales South Dakota team for allowing us to use this project for our senior design class. So to give you an overview of our project, we learned from our sponsor that air source heat pumps have become much more efficient and popular in recent years. And if you're unaware with how heat pumps work, depending on the outdoor temperature, an air source heat pump can output 4 times or more the heating energy that it consumes in electricity. That is what makes it so energy efficient. So why isn't it used more often in colder weather climates like where we live in the Midwest? Well, using some simple calculations, it is estimated that the annual cost to heat a 1,000 square foot home in our area with a natural gas furnace would cost roughly $1,350. But what would that cost if we were to use an air source heat pump under the same conditions? With this information, our goal is to develop a model that compares the cost and energy use of an air source heat pump system versus a natural gas furnace and condensing unit combo in any commercial building. Our model will be able to determine if an air source heat pump is a more cost-effective option than a natural gas furnace condensing unit combo in any location. We will then compare the pros and cons of each system to determine which is more ideal for the desired location. If one system is determined to be more cost-effective than the other, then we will determine what the cost of natural gas or electricity would need to be to produce an equivalent annual cost between each system. We will also determine any other variables that may be considered when selecting a system.
As seen in this map of typical heating choices by region, South Dakota is in the red region, which signifies that a natural gas furnace with condensing unit is most common. However, with air source heat pumps becoming increasingly efficient, these regional lines could shift north into parts of South Dakota. One of the goals of our project is to determine exactly how far north these lines will shift, given that the air source heat pump is capable of performing at low temperatures. This is a visual representation of how a natural gas furnace works. Air is blown over a heat exchanger that has been heated by combusted natural gas. This air is then sent out into the ductwork to supply heat to the building.
You might be wondering, how does a heat pump work? Well, the key concept of a heat pump is that it does not generate heat. It simply moves heat from one place to another. A furnace creates heat that is distributed throughout a home, but a heat pump absorbs heat energy from the outside air, even in cold temperatures, and transfers it to the indoor air. The same process can be done in reverse to remove warm air from inside a home and release it to the outside air for cooling purposes. Now taking a look at natural gas furnaces versus heat pumps and their pros and cons. The biggest pro for a natural gas furnace is that the cost of natural gas is very low right now. Some high-efficiency natural gas furnaces can have an efficiency of 95% or better, and they can operate at that efficiency no matter how cold the outdoor temperature is. The one exception to this is that high-efficiency furnace exhaust pipes tend to freeze up during really cold weather. Another con of natural gas furnaces is that they release CO2 into the environment. The last negative of natural gas furnaces is that they cannot provide AC. The first pro for air source heat pumps is that they are very efficient at mild temperatures. Secondly, they produce no exhaust, making them environmentally friendly and unlikely to freeze up in comparison to natural gas furnaces. Furthermore, heat pumps can provide both heating and cooling, so they don't need an additional AC condensing unit. For a heat pump, the biggest con is that right now, electricity is roughly 3 times as expensive as natural gas. Another negative is that they may require auxiliary backup heating if the outdoor temp is very low.
Although the cost of electricity is greater than the cost of natural gas, if a heat pump has high enough COP values at the common low temperatures that it will have to run at, the heat pump may still be able to even out the price difference. The coefficient of performance, or COP, of a heat pump is the ratio between the energy consumed by the compressor and the amount of useful cooling or heating energy released into the room. Theoretical COP values can be found by calculating the difference between the condensation and evaporation temperatures at different outdoor temperatures, using the equation to the right. As you can see in the graph, the smaller the temperature difference is, the higher the COP is, and the higher the COP is, the lower the cost to run the heat pump is. Using weather data for the desired location and the provided COP values of our heat pump, an annual cost to operate the heat pump can be calculated.
Using bin weather data, along with efficiency factors from air source heat pump and natural gas furnace spec sheets, we will be able to create a cost analysis model to compare yearly energy cost. Once we have created this model, we will compare overall cost for 3 different scenarios. The first scenario is a remodel, in which a working natural gas furnace will be thrown out and replaced. The second scenario is a replace, in which the current natural gas furnace already needs to be swapped out. The third scenario is a new build for a system that is designed specifically for an air source heat pump. Some additional factors that will be added into the final costs are installation cost and initial unit cost, which will depend on the type of scenario and location of the installation.
Our future project objectives include developing our current cost analysis model even farther, acquiring more accurate bin weather data for specific locations, and constructing an EQuest model for each system. These are the objectives that we will be working on this summer and into next semester to further improve our project.
Thank you for watching our presentation.